So, so this week we focus on the great common factor and group factor. Just factor, you guys definitely learned factor before. All right, so let's go see some common example. So factor, when you guys definitely learned in the pre-algebra or more earlier one about common factor or greatest common factor. Greatest common factor, like this one, 28 or 40, like this kind. So numbers, they can break it down, right? They can factor into, say, 28. Actually, you can, they possibly have factor is what? 2, right? The minimum goes 2. They are odd number. They can break it in 2 times 7, right? What about 40? They can break it down 2 times 2 times 2 times what? 5, right? Right. So their factor common part. 2 is their common part. This 2 is their common part. So what's the greatest common factor? It's this part, right? 4. 4 is their greatest common factor. This is the common part. This is not their common part. So the greatest common factor for these two numbers is 4, right? You know that. You guys can know that, right? This can get it out. Do you guys got this? All right, let's see another example. Say 55. We know 55 can break it down into 5 times 11, right? What about 21? This one can break it down 3 times 7. This is all prime number, right? You can see this is all prime numbers. They are not composite numbers, right? Prime number. All right. So what's their greatest common factor for 55 and 21? They are, looks like nothing. They are actually only is 1, right? The greatest common factor is 1. They are not. They are other than 1. They are not common factor. So what about 3 numbers? Well, there are 3 numbers. 3 numbers, we just actually find the common factor in the 3 numbers. Let's see 15. 15 can break it down into 3 times 5, right? 18, you can break it down. First is 2, right? Times 3 times what? 3, right? 66. So you can break it down 2 times 3 times 11. So what's the common part? Common part is 3, right? They all have 3. Other than that, they are not common part. So their greatest common factor is 3, right? They are GCF. Greatest common factor is 3 for these 3 numbers. So we extend this part. You learn this one in the pre-algebra. We extend this part in the algebra. Algebra means we introducing some variables. So we can see the similar thing here. So let's see this example. This has 3 terms. So this is x cubic. Actually, you can write x times x times x. If you can do factorial, basic factor is x, right? So x power 7, you actually have 7x, right? Here, so you have 3, this is 4, right? So x power 5 actually is what? 5x times together, right? So what's the common part? Here 3x, the first, this is common factor, this is a common factor, this is a common factor, right? Other than that, there's no additional common factor. So the biggest common factor, the greatest common factor is x cubic, right? X cubic. So here is their not common part. So their greatest common factor for these examples will be x cubic, because of this first common factor, second common factor, third common factor, greatest common factor x cubic, right? So actually means this one is x cubic times 1. This one is x cubic times x power 4, and this x power 5 x cubic times x squared. So we can easily find out here for this greatest common factor actually is y, right? The first one only y. Second one, y power 4, y power 7. So y is their greatest common factor, right? So this is a very good example to show us how to find the greatest common factor. All right, so we go a little bit further. So when we go to these kinds of terms, more complicated terms, more how to find their greatest common factor. So they are including, like this example, 6x squared, 10x cubic, and negative ax. So actually numbers, they made of coefficient and variables. So coefficient have they just like the first one section here. They have the greatest common factor, right? 6, 10, negative 8. 6, 10, negative 8. So actually you can say 6x squared. Actually this one equal what? 2 times 3 times x times x, right? 6x cubic. So this one equals what? 2 times 5 times x times x times x. We can break it down, it's a little bit further, right? So negative ax equal what? Negative 2 times negative 10 times 2 times 2 and x. That's it. So what's the common part? Common part is 2, right? 2, sorry. This 2, 2, 2. We find this 2 first. And second one is x. This is the common part. 2 is their common part. X is their common part. Other than that, there are no common part, right? So the greatest common factor for these 3 terms actually is 2x. 2 comes from here, x comes here, right? Right? Is it correct? All right. So let's see this example. There are 3 terms: negative 18y squared, negative 63y cubic, and 27y power 4. So these kinds of terms, we do the same. Negative 18y squared actually can break it down into what? Negative 2, right? Times 3 times 3, right? And y. Of course, if you guys can write a little bit better way. I just break it into 2 prime numbers, and even just like they cannot further factored, right? Let's see in second one, negative 63y cubic. So here is equal negative, first we can find 3, right? Negative 3 and 21, right? Times 3 times 7. Actually, negative 3 times 7. And y, and y, right? The third one, positive 20y power 4. So 27 can break it down to 3 times 3 times 3, and y, and y. So you can see, can easily find out what's the common factor. 3, right? Another 3, right? Actually 9. 9 at least they are a common coefficient. And y squared, this is their common part, right? So you can get a 9y squared is their greatest common factor. Is it correct? All right, let's see number C, this kinds of expression. So first one is a cubic b squared. This one we just break it down like this. Right? So a power 5 b. So a you can have 5a here and 1b. So a 6 b squared. So we don't actually, so most of the time I want to let you guys well understanding, we do like this way. We say, yeah, we have 3a, right? Is the common part. Only 1b is the common part. So the greatest common factor is a cubic b, right? So actually from visually, we can, if you align up here, you can see this a cubic, a power 5, a power 6, a cubic is their common part, least common part, right? And b squared, b. So b is their common part. You can quickly get here as well. We don't necessarily go here. we didn't go so much details. We got the greatest common factor is a cubic b, right? Understand? So we just need to line up. We can easily find the greatest common part, like a cubic, a power 5, a power 6. Actually, a cubic is their common factor, and b is their common factor. So put on them together, there is like a cubic b is their greatest common factor, right? So why we need a greatest common factor? We need a factor. Why we need a factor? Because we try to simplify the expression, make a expression, just like we now we do the division. Actually, is somewhat find their greatest common factor, but it's different way. So that's why here, actually, we try to make the expression easy to understand, to describe, right? So you can see when there is two terms, these kinds of binomial, we try to factor them. Because of 60 plus, we try to make it earlier we distribute inside, and finally got here. Actually, you can see this binomial, like this example, 60 plus 18, this kinds of expression. So we want to factor, we're trying to factor in, make it more different kinds of expression, right? So you can see 6t, 18t, 6 is their common factor, right? We can take 6 out, t plus 3. You can consider this is one term, this is another term, right? The greatest common factor is 6, right? We take 6 out. Earlier, we do the reverse progress. We do the distribute inside 60 times 3, you got a 60 plus 18, right? Right. So we do the reverse progress. Same here. You suppose there's a two-term binomial. So we want to factor them. We find their greatest common factor. You can say y power 5, y power 7. Actually, greatest common factor is y power 5, right? So you y minus y squared. So if you distribute inside, definitely go backward. So this is very easy one for you guys because you guys learn the distributive methods. So you can easily find this common factor and then take the great common factor, put it in the front and the rest. So if you do the reverse progress, actually it's distributive methods. So the greatest common factor as this progress is exactly the reverse progress of the distributive methods, right? So there's more example here. Definitely is the same as the one. So when there's trinomial, just like they have 3 terms, when we try to find factor, we find the greatest common factor first. So like a negative, this is 1 term, 2 term, and 3 terms, right? The 9, so we find the coefficient part first. Negative 9, 18, negative 3. The greatest common factor, we say negative 3, we take a negative 3 out. What about a? A power 5, a squared, a, so only a, right? So the greatest common factor is negative 3a. The rest will be 3a power 4. Here is negative 6a, right? And plus 1. So if you distribute inside, actually you go backward, you got a last result. So you can see these 3 terms, they are prime to each other. They don't have any common factor now. Let's see more example here, something like these 3 terms. So you can see negative 8, this is 1 term, 2 term, and 3rd term. Yeah, so coefficient part, they have a negative 8, 16, and negative 8. Definitely negative 8 is one of them, the common factor, greatest common factor for the coefficient. What about b power 6, b power 4, b power 2? The b power 2 x b squared is one of them, right? So here left behind is b power 4 and negative b 2b squared and plus 1, right? Right. So there's cannot be. Can this one be further factored? Thinking about it. You guys thinking about it? Actually, this part, you can see this part actually looks like they cannot be further factor, right? But in near future, we can be further factor. We call group factor. We need group factor. Because we remember what are we doing here? Did you do this one before? This one is B first term square, right? Second term square. And plus 2 times first term and second term. Right? So here is B power 4 negative B squared plus 1. See, exactly. So it means this part actually can be further factor. But from our first region, first to see these three terms, looks like they have no common factors, right? They cannot be further factor, but actually this part can be rewritten like this. So how we do this one? All right, so this is great common factor and distributive methods. You learned before, you can do that. So this step, right now we need to go to group factor, called group factor progress. What a group factor? So you know the GCF, great common factor, but what's the group factor? What's group factor? All right, so actually this part is group factor. What's the group factor? Actually, we break it down this just middle one into 2. You can see this is negative 2bx, right? So we group this one. We take this as a group and this as a group called group factor. So you can see in first 2, they have a common factor is b squared, right? So b squared minus 1. In second factor, we take it out, negative 1 out. Negative 1 we consider is one of the their great common factor. So right now, what do you see here? This expression, this is b squared times b squared minus 1. And this is negative b times the parenthesis, the group 2 terms inside the parenthesis, right? So we consider, you can see this is one of the expression. 2 term times something. This 2 term times negative 1 here, right? So this part is their common factor now. Something like this 1 times b squared minus 1. And negative 1 times b squared negative 1. So this part is their common factor, right? So the rest one, we take it out. B squared minus this one here, negative 1 here. So actually we rewrite b squared, right? So this is exactly here. So this is called group factor. Let's see more detail. I know this is maybe a little bit confused to you right now. But let's see next step. So we can give more examples so you can be well understanding what's group factor. All right. So just like a saying, in some polynomial expressions, they have these kinds of expression. This kind of, they have 1 term times these 2 terms. Use these 2 terms actually use the parenthesis like to describe here, and y times here. So you can see this is a group, and this is an expression. This is another expression. And they have a common factor x plus 3, right? So this one, we can take it out first, 5 plus 1, right? So actually earlier when you do the FOIL methods, you first, or distributing methods, you what? You say, I consider this is 1 term, distribute it here first, and then distribute it here. Did you see? It's exactly backward, right? Back progress. So we can easily see this kinds of example. This is example here, say y minus 2 in this expression is one of the factor, right? Y minus 2 is one of this factor. So y minus 2 is the common factor. We take it out. The rest is here. So when you do distribute inside here, time first and distribute here second, so you would have got a back one. So you guys can easily find out the third example. A plus B is the common factor, right? So you can distribute it right inside quickly, right? And you got backward. Fine, sound make it down, pull out. This last one here. See, so here if P plus Q is the common factor in this two expression, right? The P plus Q is the factor. So the rest, right? So you can quickly get a backward, get a layer group factor. Actually, this is the group factor. Because of their group factor is means they are not made one term, they're multi-terms. Right. So this one give you obviously, you can visually see they are y minus 2, a plus b, q plus q, p plus q is the common factor. Brian, your mom call you. No. Brian, go upstairs. Go. Right. So you can quickly to find out their common factor, group factor out of there. So if you follow distributed inside, you will cannot easily get the group factor, right? So something like the right part. So how we do that? In the right part, how we do that, guys? Okay, we find some group length. All right, let's see this one. We try to group this one. All right, how we group this one? You can see here, x, y, 2x, they have a common factor x. But when you consider these three factors, three terms, they don't have the common factor, right? Because of x is common factor for these two terms, but not a common factor for these terms, right? Right. So it's not easily to be determined. Okay, so if you continue down to look, oh my gosh, this one, if you find the greatest common factor is impossible. Looks like only one out of there. So how we maybe have some group factor to them for here. So how we pick group, something like, do you want to pick these two as a group? That's not easy, right? Because that's not a common factor here, right? X, Y, 6, their common factor is 1. And 2x and 3y, their common factor is only 1 out of there. So when try not group like this way, you can group. So how to group them? We can pick first two or we can pick this one, or we can pick with first method, we can pick this one first and group these two as group, these two as a group. First, so we can pick these two as group, pick these two as group, all right? So you can see this one have the common factor, right? So we take x is their common factor, so y plus 2. And this one, their greatest common factor is 3, right? So y plus 2. So right now we can more visually to see y plus 2 is their common factor. So we can put y plus 2 right here. The rest is this one, right? So when you do the Fourier method, you distribute methods. You distribute, first step is go here. Second step, you can go to here. So actually it's reverse progress of the Fourier methods, right? Okay. People may say, why I cannot pick these two as a group? Yes, you can, definitely you can. Let's do this one. Pick these two as group and pick these two as another group. All right, so what will be changing? So first, y is the common factor for x, y, and 3y, right? So the rest is x plus 3. The second group is 2x plus 6. So 2 is their common factor, x plus 3. So x plus 3 is their visually group factor here, right? So we take this out and y plus 2, right? So when you do distribute inside, you can go backward. Okay. So actually they just reverse, they are the same. The result is exactly the same. All right. Okay, everyone take your notebook out. Group this one. And first, let me say how many people group this one and Take your notebook, group list one, and write the answers on the screen. And if you correct, you can leave in, right? You can group factor by grouping factor. You can pick, you cannot pick X, Y, and 12. They have no common factor, right? Something like here. So you can pick this as a group or pick this as a group, all right? Take your notebook out, write your answers on the right part. Write the white screen part area, any part of here. Do this one. And if you correct, you can leave in. Copy down on your notebook. Did you guys done? Someone write the answer on the chat part, right? I thought someone write the answer on the chat part. Yep. Okay, let's do this one quickly, all right? So here you can see y here, x plus 3, right? Well, second group, 4 is the greatest common factor, right? So you can go this step. So do you guys go next step? Yep, it's correct. This is Iris, right? All right, let me see. And I actually prepare more examples, but they have the same similar progress. So I will send out homework a little bit later. Did you guys have the same answers as Iris do? Okay. Right on the on the chat part. Write the answer on the chat part. And I want to see everyone answer on there. And if you did it, you can leave in. All right, see you next week. You gotta sing.
Thank you. Bye.
Yeah, Jalen, you can leave.
Thank you. Bye.
Yeah, I will send homework a little bit later. X plus E. There's no E here. Max, you're wrong. X plus 3. Okay, got it. All right. Okay. All right. See you next week, everyone. Have a wonderful week. See you later.